Hi everyone, today I'll continue to teach part 2 of previous video, which is on solving equations involving indices. In this video, I'll be explaining how to solve 4 examples, which is from example 9 to example 12, as you can see here. In previous video, I have completed example 1 until example 8. Therefore, in this video, I'll start from example 9. First, let me rewrite this equation. 4 to the power of x over 2 to the power of 3 minus x equals to 2 to the power of 3x over a to the power of x minus 2. As we can see here, digit 4, the base 4 and base 8 here has a common factor of 2 if I'm not mistaken. Yes, it's 2. And 2 and 2 here has the common factor as well. So what we can do is we can do cross multiplication whereby we can bring this entire 8 to the power of x minus 2 to go up here and attach itself to 4 to the power of x, while we can bring this 2 to the power of 3 minus x up here and attach itself to 2 to the power of 3x. Just multiply it. So let me rewrite again. So 4 to the power of x, I can multiply with a to the power of x minus 2 equals to 2 to the power of 3x multiply with 2 to the power of 3 minus x. Some student might be wondering how can we do this multiplication? Okay, so in order to do that, you just need to remember these formulas. So for example, a over b equals to c over d. So from these two fractions, whenever you encounter this type of fraction, what we can do is we can move this d and attach itself to a, or move this a attach itself to d. The same thing goes to b and c as well. If we are moving situation 1, if we are moving d and attaching itself to a, which means you just need to multiply a with d, and it will be over b equals to c. When you remove, which means when you are removing this d and attaching itself to d, which means you are trying to factorize this d. Whenever you factorize something, the remainder is supposed to be 1. Don't forget that. The same thing, if you are trying to bring this a and attach itself to d, it will be like 1 over b equals to c over ad. The same concept vice versa for b and c. If you are bringing this b and attaching itself to c, it will be like sorry, no more b, right? Forgot. Yes, if you want to move this b and attach itself to c, which means the remainder will be 1, and it will be c multiplied with d over c multiplied with b, not d. I am so sorry. C multiplied with b over d. Okay, now it makes sense. And situation 4, you can remove the c and attach itself to b. So a over bc equals to 1 over d. So I hope this method you can apply to any situation so that you can move around within the fraction to get something that you want. In this situation, if it's in fraction form, it's really hard for us to solve the equation and find what is the value of x. So we need to remove the fraction, which means we need to come up with one straight linear equation. So that is why I'm trying to bring the denominator of right hand side to go left to go left hand side, and the denominator on left hand side to go on right hand side. So that's what I did using the same concept that I did teach you just now. So now what can we do? This 2 and 2 has a similar base, which means this 2 to the power of 3x trying to multiply itself, multiply with 2 to the power of 3 minus x. And according to the rule that I did teach in previous videos, when the base are similar, when you want to multiply together, you can just add up the factor. Add up the power. I'm so sorry. So in this situation, the base is 4 and 8. In previous video, I did teach you, in order to find a common factor, what we need to do, 8 divided by 4, you'll be getting digit 2. Correct. So we can, this digit 2 will be the base for will be base for 4 and digit 8 here. So let's try it out. 2 to the power of 1 is 2. 2 to the power of 2 is equals to 4. And 2 to the power of 3 is equals to 8. And we found the value that we want. So for 4, digit 4, we can replace it with 2 to the power of 2. Oops, sorry, I accidentally erased everything. I'm sorry for the trouble just now. I did rewrite everything already. So let's try to expand this bracket. Oh, before expanding, yes, we need to change the base to 2, as 2 is the common factor for 4 and 8. So let's try. So 2 to the power of 1 is equals to 2, 2 to the power of 2 is equals to 4, and 2 to the power of 3 is equals to 8. So we managed to find what is the representation of 4 and 8 in terms of base 2. So let's convert for 4 first. For digit 4, we need to change it to 2 to the power of 2. So 2 to the power of 2, don't forget the x, and then this we're supposed to multiply, correct? Multiply with 8x. 8 we can replace it with 2 to the power of 3. So 2 to the power of 3, open close bracket, don't forget, and then copy back the power. X minus 2 equals to, I'll just copy back everything. We're supposed to multiply with 2 to the power of 3 minus x. As you can see now, we managed to convert the base to be the same for everything on left hand side and right hand side. So that's what we want, correct? So let's expand this bracket first. So when we expand the first bracket, it's going to be 2 to the power of 2x. The second bracket is going to be 2 to the power of 3x, as 3 multiplied by x, when we want to multiply with x is 3x, and 3 multiply, when we want to multiply with negative 2, is going to give us negative 6, equals to 2 to the power of 3x. I'll just copy back again. Okay, now since the base is the same, when we want to multiply with each other, we can just add up the power together. So 2 to the power of 2x plus with 3x minus 6, and on right hand side 2 to the power of 3x, and then plus with 3 minus x. Alright, since the base is already, we managed to make it similar on left and right hand side, so we can just take the power and equate it together. So 2x plus 3x minus 6 equals to 3x plus with 3 minus x. So 2 plus 3x equals to 5x minus 6 equals to 3 minus x equals to 2x plus 3. So 2x, let's bring it to left hand side, and negative 6 we need to bring it to the right hand side. So 5x minus 2x equals to 3, copy back, negative 6. When you want to move it to right, it's going to be positive 6. I'll continue here. So 5 minus 2x is equals to 3x, and 6 plus 3 is equals to 9. So x equals to 9 divided by 3. 3 we need to bring it to right hand side, which is equals to 3. That's it. Very simple. Now let's try to solve example 10. Example 10 is very similar to example 9 that we did just now. So first of all, let me rewrite the equation. 27 to the power of 2x over 3 to the power of 6 minus x equals to 3 to the power of 2x plus 1 over 9 to the power of x plus 3. So again, we need to cross multiply it so that it will become one single linear equation. So let's do it. 27 to the power of 2x multiply or times with 9 to the power of x plus 3 equals to, copy back this, 3 to the power of 2x plus 1 multiply with this one, 3 to the power of 6 minus x. So now as we can see, the base on right hand side is already the same to each other, but on left hand side it's not the same. So we can't change 27 to the base of 9, because 9 to the power of 2 is 81. Alright, so what we need to do is we can try to change to base 3. So just to verify, let's try to divide 27 divide by 9. So 27 divided by 9, we're getting 3, which means 3 is the common factor for both 9 and 27. So 3 to the power of 2 is equals to 9. 3 to the power of 3 is equals to 27. Alright, so what we need to do now, as usual, 27, we need to replace it with 3 to the power of 3. So let's do it. 3 to the power of 3, make sure to open and close bracket, copy back this 2x, and then multiply with this 9. Right now, we need to replace it with 3 to the power of 2. 3 to the power of 2, open and close bracket, x plus 3, don't forget the power again, and then copy back everything. 3 to the power of 2x plus 1, maybe we can equate this thing instead of rewriting. So since the base is the same on right hand side, right? So when you want to multiply together, as I did teach you previously, we need to add the power together. So you write the base 3 and then add up the power. So 2x plus with 1 and then plus with 6, plus with 6 minus x. All right, so since we want to add everything together, let's before that we need to expand this. So let's expand this bracket. So 3 times 2 is 6x, okay, times with 3 to the power of 2x. 2 times 3 is 6, plus with 6, so equals to 3. Let's add up together. 2x minus x is x. 1 plus 6 is equals to 7. All right, so now 3, this one also we need to add the power together since the base is already the same. So 6x plus with 2x plus with 6 equals to 3 to the power of x plus 7. So here 3 to the power of 6 plus 2x is equals to 8x, and then plus with 6, correct? And then equals to 3 to the power of x plus 7. We're just copying this back. So now since the base is already the same, we can take the power, I'll write it here, and equate it together. So 8x plus with 6, and then equals to x plus 7. Again, x we need to move it to left hand side, and 6, digit 6 we need to move it to right hand side. So 8x minus x, as we are moving x to left, it is going to be negative, equals to 7 minus with 6. So it's going to be 7x equals to 1. So x is equals to 1 over 7. That's it for example. Now let's look at example 7. Example 7 is a little bit different. As we can see, the base has no common factor. If you even try to divide 5 with 2, you're going to get decimals. You're not going to get any integers. So in question like this, where we cannot change the base to be the same to each other on left hand side or right hand side, we need to play around with the power. So let's look at this in specifically. So 2 to the power of 2x, what we can do is, can we factorize this x out? So it will become like this: 2 to the power of 2 factorize x out. We can do this, right? So then we can compute this 2 to the power of 2. We are going to get 4. Am I right? 4x. And then when you expand the bracket again, it's going to be 4x like this. It seems to be tricky, but it's not that hard actually. We just need to follow this method. So now when we want to replace this 2 to the power of 2x with 4x, because we just managed to compute this, correct? So let's try it. 4 to the power of x times 5 to the power of x times with 8,000. So according to one of the rule, if you can recall from my first video that I did upload recently, so a to the power of x, when you want to multiply with a to the sorry, not a again, I'm so sorry. When you want to multiply with b to the power of x, the rule is very simple. We can multiply this a and b together and then put this x outside. It's very simple as that. So we are going to use the similar method here. So 4 and 5 we can multiply it together, so it's going to be 20, right? So the x we can factorize out like this, equals to 8,000. All right, if I open the bracket, it's going to be the same also. It's no much difference. So 20 to the power of x is equals to 8,000. So now it seems to be very easy. So 8,000 we need to make it to 20 and 80. We need to find a common factor so that we can change it to the same base. So let's try. Let's find for 8,000 and 20. So 8,000 divided by 20, we're going to get 400. Divide by 20 again, we're going to get 20. And then divide by 20 again, we're going to get 1, which means this 20 we need to multiply 3 times, correct? 1 times, 2 times, and 3 times. Actually, let's try 20 to the power of 2, we're going to get 400. So 20 to the power of 3, we're going to get, hold on, 20 to the power of 3, we're going to get 8,000. All right, 8,000. I hope you can understand this specific part. So this is how we can find the common factor. We found the common factor is 20 right now, right? So since 20 to the power of 3 is 8,000, we already know that x is 3. But in order for us to get some marks, or for you to understand further, we can simply convert this 8,000 with 20 to the power of 3. So 20x, I'm copying back, and then equals to, replace this 8,000 with 20 to the power of 3. So 20 and 20, the base is already the same right now. So x is equals to 3. Very easy, right? Now let's look at more challenging examples. So in part A, it is asking us to solve the equation 2y squared minus 7y minus 4 equals to 0. So this is quadratic equation, correct? Quadratic equation. So we just need to solve the quadratic equation on finding the roots, which is y. So let me rewrite. So 2y square minus 7y minus 4 equals to 0. So usually you can just use your calculator to find the root. Correct? Most of the modern calculators has the function to find the root straight away. But however, we need to do a steps once we found the root. Okay, so the root for y, when you try to use your calculator, you're going to get y equals to 4, the first one. And the second one, you're going to get y equals to negative 1 over 2. So don't forget, your calculator will be giving the answer straight away, but you need to show a method on how you're getting the answer. The method has a certain mark as well. So what you need to do, so you need to, let's focus on y equals to 4 first. So you need to move this 4 to left hand side. So it's going to be y minus 4 equals to 0, correct? So we need to take this value and put inside a bracket here. So y minus 4, close bracket. Let's focus on this one. So y equals to negative 1 over 2, right? So for this one, we can't straight away put it as if y plus 1 over 2. We can't do that. So what we need to do is we need to move these two up using the cross multiplying thing that I did teach you just now. So it's going to be 2y equals to negative 1. And then you need to move this negative 1 to left hand side. So it's going to be 2y plus with 1 equals to 0. Now we need to take this value and put inside another bracket. So 2y plus with 1, close bracket, and that equals to 0. Whereby this is your method, or this is the method on how you find your root. So this is very important. So you need to make sure that this line is being written in your exam in order to get full mark. Okay, let me erase. So once you did write this method or this line, you can just erase this. No issues. All right. Okay, let me get another pen. So once you find your value y equals to 4, y equals to negative 1 over 2, right? So use your answer in part A to solve the equation of 2 to the 2 something. Let me write this equation. It's pretty simple actually. So 2 open bracket 2x close bracket 2 minus 7 times with 2 to the power of x close bracket minus 4 equals to 0. If I compare with this equation, let me write it again. 2y square, if you can see the pattern, is very good. Minus 7y minus 4 equals to 0. And from this pattern, what we can see is y is equals to 2x, correct? The rest is exactly the same. 2, the square is written, minus 7, and then y again. Okay, and then minus 4 equals 0, which means in the second equation, they just did replace this y with 2x, which means we can conclude that y is equals to 2 to the power of x, correct? So we need to use the value that we obtained for y and then match with the conclusion that we found to find what is x. So for the first one, the value of y is equals to 4, correct? And the conclusion that we found is y to the power of 2 to the power of x. So y is equals to 2 to the power of x. So instead of y, we need to replace with digit 4 for the first one. Okay, for the first one, 4 is equals to 2x. So this is the basic thing that we need to know. By this time, by right, you should know what 2 to the power of what is equals to x, correct? So we can straight away skip all the method that we learned just now because it's pretty simple, right? So we already know 2 to the power of 2 is always equals to 4, right? So 2 to the power of 2 equals to 2 to the power of x. Now we managed to make the base to be the same. So the answer is, we can just take the power, x is equals to 2 or 2 is equals to x is the same thing. Alright. For the second one is quite tricky. Instead of y, we need to replace with negative 1 over 2. Negative 1 over 2 equals to 2x. 2 to the power of x. Right? Because we need to replace y 2 times since we got 2 different y value. Okay. Now, it seems to be a little bit tricky, but it's not as tricky as we think. Why? Because these two, I can simply bring it up, correct? If I bring it up, because this is indices, remember, we cannot do it with any fraction. It's quite hard to do it. So, negative 2 to the power of negative 1, okay, is equals to 2x. As we can see now, there's actually no solution for this. Why? Because we cannot simply move this negative to right hand side or left hand side. There is a negative. Okay, anything, how can I put this? Okay, 2 to the power of anything, you won't be getting any negative value. I can test it out for you. Okay, just try 2 to the power of 1 is equals to 2, correct? So 2 to the power of 2 is equals to 4, and so on. It's just the number is increasing. It's not getting, you're not going to get any negative value. The same thing, if you put 2 to the power of negative 1, you're going to get 1 over 2, correct? 2 to the power of negative, you're going to get 1 over 2 square, which is 4, which means there is no negative value. No matter what what are you trying to do, you're not going to get any negative value. Even if you try to use decimal, the number a number which is lesser than 1, for example 2 to the power of 0.5, you're going to get 1.41 something, which is lesser than 1. But no matter what you try to do, you won't be getting any negative value. So whereby the answer on left hand side, we are getting negative, correct? Negative 1 over 2 equals to 2 to the power of x. So the conclusion is we can't really find x for this specific part, which means no solution. Just leave it like this, no solution. So there's only one x value, which is 2. There is no solution for this. So you can just leave it until here, no problem. All right, and that's all for this video. If you feel that this video is really helping you, please help me to like this video and subscribe this channel so that you can stay updated with more educational video that is related to mathematics or additional mathematics.